So oftentimes we will have a situation where we know how much something cost when you first bought it. You'll know how much it's worth now. You'll know the rate that it's going down, but you won't know how long it has been that it's been going down by. So how can you solve for the time? So in this specific problem, the car was originally worth 28,131.46 cents. It's 28,131.46. And this is adjusted for inflation dollars. You'll see why, because the dollar amount is going to be depreciated for a long period of time. So it's now worth it's now worth 1,396.16 cents. So it's gone down quite a lot in value. And we know the depreciation rate, so that is 12.76%. What we don't know is X. We don't know how long. Could be a decade, could be 2 decades, we're not sure. We're going to figure it out. So we take all of this and we plug it together. So 28,131.46, and we're going to multiply it by our B. B is equal to 1 minus R. So that is times 1 minus, and this is percentage. We want to divide it by 100 to find out what our R is, because it's in decimal land. So that's 0.1276. And we don't know X. We don't know X. But we do know what it's equal to now. So we know what it's equal to now, we know how much it was equal to, and we know the rate at which it's gone down. So we could, I guess, simplify some things. So 1 minus 0.1276, I don't have that in my head. I cannot do that off the top of my head. So that's 0.8724. Okay. Get that to the x power. We multiply that again. We'll take everything down. Just simplify. Okay. So we want to get x alone. So one thing we can do is we can divide. We can divide this from that. So we now have 28,131, this in a box, 0.46 on the bottom, 1396.16 on the top, equal to 0.8724 to the x power. Now, to undo an exponent like this, when we don't know how many times, we can't raise it to a specific power. We can't raise it to a 1 over x power. What we want to do is we want to use logarithms, because logarithms have some cool rules that they have, which we can use to undo our operations. So I am going to take everything to the log of it. Okay. When you put something to a logarithm that has an exponent in it, there's this really cool thing, at least I think it's really cool, that you can do. And that is, you can take this x, if it's a truly an exponent, and you can pull it out of the logarithm and put it in front of it. Okay, so we're almost done. Now, let's use the green color so we can see where our variables are going. Now, we want to get x alone. So to get x alone, we are going to take and divide both sides by the logarithm of 0.8724. So we're going to end up with x equal to the log of something over the log of 0.8724. This is going to be 28131.46. And then on here, 1396.16. So it looks like a lot right now, but we're basically done. You can leave it like this, or if you're being tortured and you have to use a slide ruler, use a slide ruler, or you can just put it into a calculator. So the TI-84 and other models is very handy. You just hit log, you type it in, 1396.16 divided by 28131.46, end bracket, or in parentheses, divide by log of 0.8724 equals, and it tells me right away the answer, which is 22 years. So x is 22 years. So all you have to do is put everything into the equation. And once you do that, you'll see really quickly what you do and don't know. And if you don't know what the variable is in the exponent, you just have to do a log of both sides. The exponent pops out in front of the log because of our logarithm rules. And then you divide by this. You get a wonky big fraction of two logs over each other. You do the operation in your calculator and you're done.